So folks, we could spend a whole lot of time looking at functions, going back to the very basics of them. But because this course assumes that you've had a little bit of exposure to them, I want to jump straight into what I want to talk about today. So what we want to look at today is how can I take two functions, maybe this function f of x, which is this quadratic x squared plus x plus 7, and this function here, g of x, which is the linear function, 3x minus 2. We could ask, how could we combine these two functions in such a way that we create a new function? And there's lots of ways we could do that. For example, we could look at adding these two functions together. So we could create this new function. And if you like, you could give it a brand new name. Like I'm calling it f plus g of x, but if you wanted to give it a brand new name like h of x, you're welcome to. But how do we construct this new function? Well, what we're going to do is we're going to take f of x and simply add it to g of x. So we're taking the outputs of f and adding it to the outputs of g. So you take an input, plug it into f, gives you an output. You plug an input into g, it gives you an output. We're going to add the two outputs together to get the sum of these two functions. So this is really straightforward in that all I have to do is take the first function, and it makes sense what it means to add them together in the sense of adding polynomials or adding expressions that we've seen before. And so we end up with the new function, x squared plus 4x plus 5. This is this new function, h of x, which I obtained by adding together f of x and g of x. So that's something that hopefully you've done before. And there are lots of ways we can combine new functions to get those functions f and g to get a new function. For example, I could find the difference of the two, but of course difference is not commutative, so I could do it either way. I could find the difference between f and g, or the difference between g and f. I could find their product. And how would you find the product of two functions? Well, you would just take the output of one function and multiply it to the output of the other, and it turns out that that's really well behaved, and that's something worth looking at. Or I could take the quotient. Remember, the word quotient means division. I could take the quotient of these two functions, where I take f of x divided by g of x, or g of x divided by f of x. Okay? And all of these, I should tell you, we need to be careful. Be careful with the domains. I'm not going to get into that topic in today's pre-work, but that's something that you should always be careful with whenever you're combining new functions from old ones. The final thing we can do with functions, so we've just talked about how we could add two functions together, we could subtract one from the other, we could multiply two functions together, we could divide one by the other. The final thing we can do with two functions is we can compose them together. So I could either find f composed with g of x. So this is red, f composed with g of x. So I can compose the two together. And composition is generally not commutative, meaning changing the order, saying f composed of g of x is different than talking about g composed of f of x. So let's run through the paces here. What does f composed of g of x mean? Well, by definition, f composed with g of x is equal to f of g of x. That's from definition. So what does it mean? It means I take the function f, and everywhere I see an x in my expression f, I'm going to replace it with the function g of x. So what I'm going to do here is, let's see here, and there's lots of ways I could write this, but my function f of x in this case was this quadratic, where I had something squared, the independent variable squared, plus the independent variable plus 7. And then what I'm going to do is I'm going to place the function g of x in where you would normally have an x. And you can see that's exactly what the notation indicates we should do. Well, what is the function g of x? Well, the function g of x was this linear function, 3x minus 2. So everywhere I see g of x now in this expression, I'm going to replace it with 3x minus 2. Now all I have is some large expression, and in fact I could leave my answer here, but it's customary and it's polite to your reader to go ahead and clean it up. So we're going to actually clean it up. But this is the result of having done the composition of these two functions. So let's check this out. So this would be, if I FOILed this out, we would end up with 9x squared minus 6x minus 6x plus 4. Here the parentheses aren't lending any information, so it's just plus 3x minus 2 plus 7. And if I were to combine together all like terms, we end up with 9x squared this would be minus 12x plus 3x, which would be minus 9x, and then we get plus 11. So we got this new function, f composed with g of x, which is now this particular, it ends up being a quadratic, 9x squared minus 9x plus 11, that I got by taking the function g of x, and everywhere I saw an x in the original function expression, remember there's the original function expression right here, everywhere I saw an x in this expression, I replaced it with the name g of x, and then I eventually replaced that with the expression for g of x. So then what I'd like to do is I want to show you how we could do this the other way. So function composition is not commutative. G composed of f of x means that we're going to take the function g of x, and everywhere I see an x in this expression, I'm going to plug in the rule, the definition of f of x. So my function g of x is 3 times the independent variable minus 2. That's my function g of x. Folks, I have an error there. That's not what I meant to write. So my function g of x is 3 times the independent variable minus 2. And I need to give myself even more room. I still didn't get it how I wanted it. So let me scoot this over just a little bit. Clean this up. Sorry, folks. And so there's my function g of x, which looks like 3 times the independent variable minus 2. Remember, that's what this reads. This reads as 3 times the independent variable minus 2. And so that's the skeleton that I've got here. 3 times, I'm going to put the independent variable here, minus 2. But what am I going to use as the independent variable? I'm going to use the function f of x. So when I do so, we end up with 3 times, and then what was the rule for f of x? It was the independent variable squared plus the independent variable plus 7, and then we subtract 2. Now all I have to do, this is, you could park your answer here, I suppose, but it's not cleaned up, it's not simplified. So we're going to go ahead and simplify it further by expanding everything out and combining like terms, and we end up with 3x squared plus 3x plus 21 minus 2, or 3x squared plus 3x plus 19, and there is the composition of f and g of x. Folks, at this point in the pre-work, all I am doing is highlighting a procedure. I haven't really explained why we would want to take the composition of two functions, and we're going to look at that in class. So for right now, we're just learning this as a procedure. We're going to get a better intuition for why this is a useful procedure later on. Okay. And the other thing is this review will not cover the important issue of domains of composition of functions, and again, we'll cover that when we get to class. Okay, I'm going to go ahead and stop there. In the next video, we'll pick up with number 4. I'll see you there.